Hi there, my name's Dr. Paul McKay and I'm going to take you through AQA 2019 GCSE Higher Maths Paper 1, which is the non-calculator paper. For some of the easier questions I won't spend much time, but for the questions that I believe are a bit more challenging, I'll spend a little bit more time on those questions to make sure everybody understands the techniques required. Okay, let's get started. So a nice easy one to start with, hopefully. This is about similar triangles. You can see as the triangles are presented, the angle in the corner is x in both cases, so same angles, so therefore the ratio of those sides must be the same. So for the left-hand triangle, 6/10 is the ratio of those sides, and that's going to be the same as y/15 for the right-hand triangle. Rearrange that, you get y is equal to 15 times 6/10, which is 90/10, which is 9 centimeters. So the correct answer there is 9. Question 2. Work out the value of 1 2/3 squared. So this is a mixed number. So what we need to do is we need to rewrite this first of all as an improper fraction. So 1 2/3, remember that means 1 plus 2/3. And 1 is the same as 3/3. So 1 plus 2/3 is the same as 5/3. So when we square a fraction, we just square the numerator and the denominator. So we get 25 on the top, and then 3 squared is 9 on the bottom. And then it's a case of putting that back into a mixed fraction form. So how many times does 9 go into 25? Well, 9 times 2 is 18, and that will leave 7 left over. So we're going to get 2 7/9, which is the last option there. Question 3, work out an arc length. So an arc length is part of a circle. So if we've got a semicircle here, basically it's asking us to find the length of that curved side of it. Now the radius, which is half the diameter there, is 6. And the general formula for an arc length is that the length of an arc is equal to the radius times the angle in radians. So the length, the radius is 6, and the angle from there to there is halfway around a circle. Now we know it's 2 pi around a whole circle, so half a circle must be pi. The answer is simply 6 times pi. Okay, question 4. Circle a fraction that is equivalent to 4.625. Now there are ways to write decimals in terms of fractions, but the easier way to answer a question like this one is just to try the different values. So let's assume that the first one is the correct answer, and let's try that. So if that was true, then we could rearrange this by multiplying 8 by 4.625. Okay, so what is that? What is 8 times 4.625? Okay, so 8 times 5 is 40. So 0, carry the 4. 8 times 2 is 16, plus 4 is 20. So that's 0, carry the 2. 8 times 6 is 48, plus 2 is 50. And then 8 times 4 is 32, plus the 5 that we carried, so that's 37. So we actually find that 8 times 4.625 gives 37, so that tells us that the second answer is actually the correct one. If you were unlucky, you would have to try all 4 to get the right answer, but it's still probably a quicker way of doing it. Next one, standard form. When we write a number in standard form, what does that mean? It means that we write it as a number a times 10 to the power of b, where a is a number somewhere between 1 and 10. So what we do is we move the decimal place until we place it after the first non-zero number, okay, which is called the first significant figure. So to place it there, we have to move it to the right 1, 2, 3, 4 places. So the answer is 9.7 times 10 to the minus 4. If we move them to the left, if we move the decimal place to the left, then the exponent there, the index, the power, becomes positive. 5b, work out this ratio as an ordinary number. Well, we can just split it up into the different parts. So 3 over 4 is 0.75. And 10 to the 5 times 10 to the 3, well, if we divide in powers, then we subtract. So 10 to the power of 5 minus 3, which is 2. So we've got 0.75 times 10 to the power of 2, which is 100. So 0.75 times 100 is just 75. Okay, question 6 is a probability question. So somebody's got a fair dice, so a 6-sided dice, equally likely to land on either of the 6 faces. And the game is that if it's a 1, it's a win. If it's 2 or 3, it's a loss. If it's a 4, 5 or 6, she has to roll again. And if she does have to roll again, then simply if it's an odd number, she wins. And if it's an even number, she loses. The first question here was to complete a tree diagram. I'm just going to draw it again separately here. So for the first roll, if it's a 1, she wins, and the chances of that happening are 1 out of 6. If it's a 2 or 3, she loses, and there are 2 options out of 6. So that's 2 out of 6, or 1 out of 3. Don't need to simplify at this stage. And if it's a 4 or 5 or a 6, she has to roll again, and the chances of that happening are 3 out of 6, or a half. And if she does roll again, then if it's odd, she wins, and if it's even, she loses, and the chances of those are 50-50. Okay, 1 out of 2, or 3 out of 6. Okay, so that's the tree diagram done. The part B there is Anna more likely to win or to lose? Well, let's just find out the probability that she wins. So the probability is either she gets a win straight away off the first roll, which is an 1 out of 6, or the other way that she can win is she can win a 4, 5 or 6, which has a probability of 1 out of 2 happening, 3 out of 6, multiplied by the probability of then throwing an odd number, which is also 1 out of 2. So if we simplify this, we get 1 out of 6 plus 1 out of 4. And to combine those together, we'll just put them over a common denominator. So 1 out of 6 is the same as 2 over 12. 1 out of 4 is the same as 3 over 12. So this is 5 over 12, which is less than 6 over 12, which is a half. Okay, so it's less than half likely. So she's more likely to lose. So therefore, more likely to lose. Okay, if that number there was greater than a half, then she'd be more likely to win. If it was equal to half, she'd be just as likely to win or to lose. 3 friends arrive at a party. When they arrive, the number of people increases by 20%. How many people are at the party? Well, let's call the number of people that were at the party to start with, let's call that P. 3 more people arrive, and then the number of people at the party goes up by 20%. Let's express that as a decimal. So that's 1.2 times how many people there were originally. Okay, so 120% of the people there, 1.2 times the original. If we try to solve this, 1.2p minus p is just 0.2p, and therefore p is equal to 3 divided by 0.2, which is the same as 30 divided by 2 if you multiply top and bottom by 10, which is 15. So there were 15 people at the party originally, and therefore now there are 15 plus another 3. So 18 people present at the party. Right, question 8, another one with bases and powers. So we've got 3 to the power of 12 divided by 3 to the power of 5. If we divide, we subtract the powers. So 12 minus 5, that's 3 to the power of 7. Divided by 3 to the 2 times 3. Now 3 is just 3 to the power of 1. So add those powers. That's 3 to the 3. And then for the last step, just subtract again. So 3 to the power of 7 divided by 3 to the power of 3 is 3 to the power of 7 minus 3, which is 4. Work out the value of that. Well, that's just 3 times 3 times 3 times 3. That's 9 times 9, 81. Okay. Question 9. Geometry question now. So we've got a circle with a semicircle shaded inside of it. And the question is, how many times bigger is the unshaded area inside there than the shaded area? Well, the key thing in this question is knowing the equation for areas of circles, so pi r squared. I'm going to have to use that. So let's work out the shaded area first. So the area of the semicircle. So that's half of a circle, so half of pi r squared. But we're given the diameter of the semicircle, so the radius is 4. So a half of 4 pi times 4 squared. 4 squared is 16, divided by 2 is 8. So the area of the semicircle is 8 pi centimeters squared. The unshaded area is just everything that's left. So that is the area of the big circle, and we're given the radius that time, so that's easy, so that's just pi times 10 squared. But then we've got to subtract the bit that we've shaded in, so we've got to subtract the area of the semicircle, which we just found was 8 pi. So 10 squared is 100, so we've got 100 pi minus 8 pi, which is 92 pi. And therefore, how many times bigger is the unshaded area than the shaded area? Well, then it must be the ratio of those things, 92 pi divided by 8 pi. And that simplifies slightly, so the pi's cancel out. Can we simplify that? 92 over 8 is that if we half the numerator and denominator, we get 46 over 4. Half it again, 23 over 2. And then hopefully at that stage we can do that in our heads. 23 over 2 is 11.5. So it's 11.5 times greater. Okay, functions now. So we've got a machine that makes items, and the number of items it makes in 1 hour is given by n is equal to 60 over t, where t is the time in minutes taken to make just one item. So the question says, on this graph which is applied, draw the graph of n equals 60 over t for values of t from 1 to 4. Well, let's just work out the integer values. So if we substitute in, just draw a little table. So t is 1, 2, 3, and 4. What values of n do we get? So 60 over 1 is 60. 60 over 2 is 30. 60 divided by 3 is 20. 60 divided by 4 is 15. And then we just need to plot these on the graph. So 60, 30, 20, and then 15 is halfway between 10 and 20. So we get that. And let's just join those up with a smooth curve, as smooth as I can draw on a computer. Okay, so that's the first bit, done. The second question says the machine takes 3 minutes and 30 seconds to make one item. Use your graph to estimate the value of n. So 3 minutes and 30. Let's go up there. So 3 minutes and 30 and then along to find n. And we get a value around about 17, I would say. So it's just a case of using the graph to then go back up from the x-axis back to the y-axis and read off the value. Okay, another one about ratios now. So Ed and Faye share £330 in this ratio 7:4. Probably the easiest thing to do in this question is, first of all, work out how much money each person has. So if they're in the ratio 7:4, then 7 plus 4 is 11. So Ed has 7/11ths of £330. Faye has 4/11ths. And 330 divided by 11, well, 33 over 11 is 3. So 330 over 11 is 30. So that's 7 times 30, which is equal to 210. So Ed has £210. And in a similar way, 4 times 30 is £120. Okay, so that's how much they have, 210, 120. Ed gives Faye some money so that they have the same amount. Well, if they have the same amount, then they're just going to have 330 over 2, which is £165 each. So how much money does Ed have to give Faye so that she has £165? Well, he has to give her another £45 then, because she's already got 120. So simple difference there. Question 12. A sequence is formed where every number is made by adding the previous two terms. This is known as a Fibonacci sequence. Okay, so you may be familiar with that series of numbers. So you take every term, add them together, and get the next term. So let's just look at these one at a time, and hopefully it might be the first one and not the last one. So minus 9 plus 2, what does that equal? Minus 9 plus 2 gives minus 7. Oh, well, that's hopeful, because that's what we've got there. 2 plus minus 7, well, that's the same as 2 minus 7, which is minus 5. Oh, that works. And then minus 7 plus minus 5, so minus 7 minus 5, that gives minus 12. Oh, well, there we are. We've got lucky. It's the first one in the sequence there. So let's just move on. If we found the right answer, there's no point dwelling on it. Next one is an estimation question. So we've got a triangular prism, and for any prism, the volume is equal to the cross-sectional area of the prism multiplied by its length. So for a triangle here, in this case, we're going to have that V is equal to the area of this triangle. So it's isosceles and both sides are x. So we're going to have a half of x squared. Okay, so a triangle, base times height, so x times x divided by 2, and then times the length. Now, what you should do here is rearrange this, because we're trying to find a value of x. So let's just rearrange this equation first. So we need to get rid of the half, so we're going to multiply 2 onto the left-hand side. We also multiply by L, so we need to divide by that. So we get that value for x squared. So therefore, x is equal to that. Okay, I'm not including the minus possibility, because we're talking about a length here, and a negative value of x doesn't represent anything meaningful. Now the question says to use approximations. So we're not going to take exactly 102, we're not going to take exactly 8.14, we're going to approximate. So we can say that x is approximately equal to, well, 102 is about 100, and 8.14, that's about 8. So we've got 200 over 8, 200 divided by 8 is the same as 100 over 4, which is 25. So square root of 25, about 5 centimeters. And there's your answer. So it's going to be approximately 5. And if you worked it out exactly, you wouldn't be far off there. Okay, there's a quadrilateral now. And again, we're told things about ratios. So we're told that angle A is a right angle, 90 degrees. The ratio of A to B is 5 to 3, so that will allow me to find B. So we've got 90 over B is in the ratio of 5 over 3. So therefore B is going to be equal to 90 times 3 over 5. And just do that on a calculator. So 270 over 5. Well, 250 over 5 is 50. So that's 54. So we've got this angle here is 54 degrees. This one here was 90. We also know that x to y is 1 over 3. So we can say that y is equal to 3x if we cross multiply. And then perhaps we're a little bit stuck, but remember it's a quadrilateral. So we know that in a quadrilateral, all of these angles add up to 360. So we're going to have 90 plus 54 plus 3x plus x is equal to 360. 3x plus x is 4x, and 360 minus 90 is 270, minus 54 is 216. So just rearranging that. And therefore x is equal to 216 divided by 4, which is 54 degrees, which is the same as B. So we've proven it. Okay, so a question like this, just write down everything you know, everything you can show for the triangle, and hopefully it will all come together. Question 15 is cumulative frequency. So we're given a set of marks in the range 0 to 10, 10 to 20, and so on. And we're told how many students are in each of those brackets. So the cumulative frequency table is just found by adding on the amount that we had before plus the next bracket. So 20 plus 28 gives us this 48. Add on the 40, that'll give us 68. Add on the 20, that will give us 88. And then add on the 12. Oh, sorry. Go back a little bit there. 48 plus 40 is 88, plus 20, 108, and then plus 12, 120. This question had a graph given, but I just got rid of that just for space. But the idea here, hopefully, everybody should be happy with just being able to plot this onto the graph. So how many people got up to 10? Well, that was 20. Let's just space this out equally. So that's 20, 40, 60, 80, 100, 120. Up to a mark of 20, well, that takes us up to 48. So 50 is going to be about there. 48 will be around there. 30 takes us up to 88, which is around there. 40 puts us at 108, and then 50 brings us up to 120 at the top there. So the graph's going to look sort of like that. Okay, drawing a smooth curve through them. So use your graph to estimate how many students will take another test. So we're told that if they score 15 marks or fewer, they'll have to take another test. So let's go from the number of marks. Should have labeled that axis as well, marks. So go from 15, go along, and if this was drawn more accurately, we may get an answer somewhere around 30, 35. Okay. So that's the graph done. Question 16, back to algebra now. So simplify fully this expression. So what we need to do is factorize the numerator and the denominator. So in the numerator, what's a common factor between those two terms? Well, each term involves an x, and 4 and 8, well, there's a common factor there of 4 too. So we can take that out as a common factor. So 4x over 4x is 1. 8x squared over 4x, that leaves 2x behind. Do the same with the denominator. What's common to both of those terms? Well, all I can say here is that a 6 is common to both. So I get 2x minus 1. Okay, so that's the first step. Doesn't look like we can do much. However, 1 minus 2x and 2x minus 1, they're just one's just the negative of the other. So what I can do is I can put a minus sign in the numerator multiplied by 2x minus 1. Okay, because minus 1 times minus 1 is 1, and 2x times minus 1 is minus 2x. And if I do that, then you can see that the 2x minus 1 terms will cancel. So I just get minus 4x over 6. And I can cancel further because 4 and 6 have a common factor of 2. So I can just write this as minus 2 over 3x. Okay, forming equations now. So we're told that Toby wants to write an equation down to describe this problem. The product of half of a number and 3 more than the number is the same as the square of the number. And we're going to use y to represent the number. So let's just look at these terms here. The product, what does the product mean? That means that we're going to multiply things together. That's what product means. Half of a number, so that's going to be the number divided by 2. 3 more than a number, so that's y plus 3. And that's the same as equals the square of the number, so y squared. So we're going to put all that together. So we've got y over 2 times by y plus 3 is equal to y squared. Okay, and that's the equation then that Toby would then look to solve. Okay, but he's not solving that one, he's solving this one instead. So he forms another equation, x equals 9 over 8x, and he wants to solve this for x. So here's his working out. Well, first of all, he multiplies the 8x to the left-hand side, so we get 8x squared equals 9. That looks right. And then he wants to get rid of the square, so he takes the square root of both sides. So square root of 9 is 3, so we're going to get plus or minus 3. That bit's right. However, when you take the square root of 8x squared, then you're going to get root 8 times x. Okay, so Toby has forgotten to take the square root of the 8 there. So that's the error. Okay, so forgot to square root the 8. Okay, so next one is about an identity. So this is called the difference of two squares. X squared minus y squared is equivalent to x plus y, x minus y. So first of all, use that identity to find the value of this. And remember, it's a non-calculator paper. So 193 squared minus 7 squared can be written using the identity. So we see that 193 is x and 7 is y in this case. So we've got 193 x plus y, 193 plus 7 times 193 minus 7. 193 plus 7 is 200. 193 minus 7 is 186. So we just need to multiply these two things together. So 2 times 186 is 372. Okay, so 2 18s is 36, 2 6s are 12, and then we've got 2 more zeros. So we get 37,200. Okay, next part, factorize this. Okay, now we're not going to do what we did on the previous question of looking at what do these have in common. Notice that this is still part of question 18, so we're still using this identity. Okay, it's important that you look at whether it's still part of the same question to know whether to do the same things. So we're still going to do this. So what we need to do is we need to write each of these two terms as just squares. So 100a squared, that's the same as writing 10a all squared. And 81b squared, that's the same as writing 9b all squared. And once we do it like that, then we can just put these into the identity. Okay, so this time x is 10a and y is 9b. So we're going to get 10a plus 9b, 10a minus 9b. And that's it factorized. Okay. Circle a fraction that is equivalent to 0.1 and there's got a dot on the top, so that's recurring or a repeating decimal. Okay, so 0.111. Now, again, you might just remember that that's 1 over 9, which is the right answer. But if you didn't remember that, how can you test it? Well, like we did on an earlier question, let's just assume each of these values. So let's start off with the first one, which happens to be the right answer. And just write 1 over 9 is equal to that. And let's just show that if we multiply the 9 across, that we get the same thing. So we get 1 is equal to 0.999999999, which is actually equivalent to, which is equal to 1. Okay. So that's the first. The first one is the correct one again. Right. Now, bit of geometry again. So A, B, and C are points on a circle. We're told that ABC is isosceles and that AC is equal to BC. So AC here is the same length as BC there. So that means that this angle here is equal to this angle here. And that's how we draw that they're equal. We draw a double angle sign or a double two lines across the side if they're equal. So what we need to show is that AB is parallel to DC. So how can we do that? Well, what we can do is CD we're told is a tangent. So a tangent line always forms a right angle with a line that goes through the center of the circle, which would be a line that goes straight down the middle of this triangle. So that there is a right angle. So what we can do is we want to find this angle here, the angle that CD is moving away from AC. So let's call that, let's use some Greek letters here for the angles. So let's call this angle here alpha, the angle at the bottom of the isosceles triangle. So let's call this one beta, and this one that we're interested in gamma. So we know in the isosceles triangle, we know that the angles always add up to 180 degrees in a triangle. So we've got alpha plus, as I've drawn it, 2 times beta. So that would be the angle going all the way across there. That's equal to 180. So therefore beta is equal to 180 minus 2 alphas divided by 2, which is the same as 90 minus alpha if we divide by 2. So that angle there, beta, is equal to that. And we know that beta plus gamma, we know that both of those add up to 90 degrees. So therefore the angle that we're interested in, gamma, is going to be 90 minus beta. So we've got 90 minus alpha. And if we multiply that out, 90 minus 90 is 0, minus alpha is alpha. So what we find is that this angle gamma is the same as alpha. Okay, so it's alternating angles. Okay, so they're the same, and therefore CD and AB are parallel. Okay. Part B says, what if it was actually an equilateral triangle instead? Then what would be true? Okay. Well, the first one is that AB is parallel to DC. That's what we've just proven, and that must still be true because an equilateral triangle is just one where all of the sides are true are equal. But an equilateral triangle is just a special case of an isosceles triangle. So we've still got two sides the same, just like we just had. So that doesn't change that at all. So now we've got, let's try and draw it sort of accurately. So we had, sorry, that was A, B, okay, it was like that, wasn't it? So if it's an equilateral triangle, then all of these angles are the same. And they're all 60 degrees, 60, 60, 60. And we said on the previous one that this angle up here was the same as this angle down here. And so we can see that AC splits this into two, 60 and 60. So that's true as well. Is the last one true? Well, no, because this angle BAD, so that's the one up here, it's 60 on one side, but we don't know where it is on the other side. That really depends where D is. Okay, if D was all the way up there, then that would be a huge angle. If D was quite close to C, that would be a much smaller angle. We don't actually know anything about the length of CD, so we can't say anything about that angle there. Okay, so it's just the first two. Right, simultaneous equation. 2x plus 3y is 5p, y equals 2x plus p. Various ways to solve simultaneous equations. The easiest choice here is just to do an elimination, so rewrite the second equation as minus 2x plus y is equal to p, so just moving the 2x to the left hand side, and then we're going to add the equations together. So 2x plus minus 2x is 0, 3y plus y is 4y, and then 5p plus p is 6p. 6 divided by 4, p, which is the same as 3 over 2p. So that's y. Now we need to find x. So let's go back to one of these equations. If I take that second equation and rearrange that for x, I've got x is equal to y minus p over 2. So x is going to be equal to 3 over 2p, that's y, minus p divided by 2. So 3 over 2p, so 1.5p, minus 1p, so that's going to leave half a p on top, divided by 2. Half divided by another 2 is a quarter. So we get a quarter p for x. Okay, and there we are, solved. We found y, we found x. Okay, vector question now. So two parts here. First of all, for just one mark, we want to find an expression for CD. So if I want to go from C to D, then the thing with vectors is I can take any route I want. So I can go from C to A and then A to D. Because I know what they are. Now A to C is 3b, so C to A must be minus 3b because we're going back in the opposite direction. And then A to D is 6a plus 7.5b. And what we do is we just combine the A parts together, combine the B parts together. So the A parts, I've got 6A, that's all I've got, and then I've got 7.5 minus 3 is 4.5. Okay, and there's the answer that I'm looking for. 22, we're also told now that BCD is a straight line. So work out the value of K from that. So if this is a straight line, then BC is in the same direction as CD. Now CD we've just worked out, but we can say that BC must be some multiple, let's call it lambda, some multiple of CD. Okay, use whatever symbol you want. So BC, now what is B to C? Well, that's B to A plus A to C. Okay, so B to C can be that plus that. So that's KA plus 3B, and that's equal to this constant, which we're going to try and find a value for, multiplied by CD, which was 6A plus 4.5B from the first part. Let's just multiply that out. So 6 times lambda in the A direction plus 4.5 lambda in the B direction. And what we know is that on both sides of the equation, the coefficients of the different vectors A and B must be equal. So we've got that K is equal to 6 lambda by looking at the A parts. And if we look at the B parts, then we can also write down that 3 is equal to 4.5 lambda. And that gives us that lambda is equal to 3 over 4.5. Okay, no need to simplify that because we're just going to substitute it back into this equation. So K is equal to 6 times 3 divided by 4.5. So that's 18 divided by 4.5. And if you multiply top and bottom by 2, that's the same as 36 over 9, which is 4. So we find that K is equal to 4. And that I would say is probably the hardest question on the exam. So if you've managed to do that, well done. Right, let's finish the last few off. Simplify this expression. So 8 to the power of 4 divided by 32 to the power of 2 over 5. Giving your answer in the form 2 to the power of m. So 8 and 32 are integer powers of 2. So 8 is the same as 2 to the power of 3. 2 times 2 times 2 is 8. So rewriting this expression in powers of 2 like this. 32 is 2 to the power of 5. If we have a power to another power, then what we do is we just multiply those powers together. So 2 to the power of 3 to the power of 4, that's the same as 2 to the power of 3 times 4. And on the bottom I've got 2 to the power of 5 times 2 over 5. 3 times 4 is 12. 5 times 2 over 5 is just 2. And then, if we remember from an earlier question, if we're dividing, then we subtract the powers. So we just get 2 to the power of 10. And that's the form we were asked to leave it in. So we're done. Okay. If you're interested, that's 1024. Quite important in computer science. Right, question 24. We've got this function f of x is equal to sine of x minus 90. Circle a value of f of 0. So what this means is that we need to substitute x equals 0 into the equation. So we've got sine of 0 minus 90. So that's sine of minus 90. And if you remember what the graph looks like, it looks like this. Keeps continuing. So sine of minus 90 has a value of minus 1. So there it is. So two fairly easy questions there. Give you a bit of a breather before this one. So we've got a circle with a tangent drawn, and the tangent touches the x and y axes at A and B respectively. The first question says, show that the gradient of the tangent is minus 1 over 2. Okay, now the easiest way to find the gradient here is to find the gradient of another line. And we know that a tangent and a normal are perpendicular. And we also know that if the gradient of this one, if we call this m tangent and this one m normal, then there's a rule that if you multiply those together, you get minus 1. Now the gradient of the normal is actually very easy to work out. Okay, so mn, so it's delta y over delta x. And we know it goes from 0, 0 up to the point 4, 8. So we can do 8 minus 0 divided by 4 minus 0, which is 8 over 4, which is 2. So therefore, the gradient of the tangent line is minus 1 over mn, just from rearranging that equation. So that's minus 1 over 2, which is what we were asked to find. Then it says to work out the length AB. Okay, so let's just quickly draw a sketch of that again on here. So that was A, that was B, and this point here was 4 and 8. And we know that the gradient of this line now is minus 1 over 2. So work out the length of this line. Well, to work out the length of a line, you just need to know the coordinates of a line, and then you just apply a bit of Pythagoras' theorem. So what we'd like to do first is find out the equation of this line. Now we know that a tangent line is just a straight line. So it is an equation, it has an equation y equals mx plus c. We know what m, we know that's minus a half. And we can find c by using a point on the line. And we know that the point on this 4 and 8 lies on the line. So if we substitute that in, we get y is equal to 4. Y is equal to 8, x is equal to 4. So 8 is equal to minus 2 plus c, so c is equal to 10. So the equation of the tangent is y is equal to minus a half x plus 10. And now we can find where it crosses the axes. So just by, we found c is equal to 10, so that's the y-intercept. So I can say that this point up here is 0, 10 without doing anything extra. To find where it crosses the x-axis, that's where y is equal to 0. So if I substitute y equals 0 into the equation of the tangent, then I get half x is equal to 10, so x is equal to 20. So this a here is at 20 and 0. And now we've got 2 points, so the length of the line from 0, 10 down to 20, 0, and it's a right angle triangle here. It's just going to be equal to, so this side of the triangle is 10, and this side of the triangle is 20 long. So we're going to get 10 squared plus 20 squared is equal to the length of that hypotenuse squared. So the length of the line is just going to be equal to the square root of 10 squared, which is 100, plus 20 squared, which is 400. So that's the square root of 500. That can be written as square root of 5 times 100. And the square root of 100 is 10. So this is 10 root 5, which is in the form that we're looking for here. An integer 10 times the square root of 5. Question 26 is turning point. So if we've got a quadratic written in this form, this is called the completed square form. And if it's in the completed square form, then the turning point of this curve must be where this squared part is equal to 0. Okay? So turning point where that's true. So if x is equal to -2, then that implies that a is equal to 2. Okay, to make that equal to 0. So let's say that y now is equal to x plus 2 squared plus b. And we're also told that we know that another point on this curve is x is equal to 3, y is equal to 1, so we can just substitute that in. So 3 plus 2 is 5, squared is 25. So b is equal to 1 minus 25, which is minus 24. And that value there is what we're looking for, because that's the value of y when that square part is equal to 0. Okay, because that's all we'd be left with. So the answer is simply minus 24. Okay, and then finally, last question is just knowing some trigonometric ratios. So sine 60 this is just something that you need to remember, is root 3 over 2. Tan 30 is 1 over root 3. And therefore cos x is equal to that times that. The root 3's cancel out, and we're just left with a 1 on top and a 2 on the bottom. So the question is, what value of x is it if the cosine of x is a half? And we're also told that x is acute, so we're just looking for one angle here. So it's 60 degrees. Okay, so cos 60 is a half, is again a trig ratio you should be familiar with. Okay, and that's it. That's the last question of the paper. So hopefully that's not been too bad. If you've liked this video and you found it useful, then please like and subscribe to this channel. And if you do want any particular maths and science tuition, then please visit my website www.physicsmathstuition.com, and hopefully I can hook you up with some useful revision there. Bye for now, everybody.